Okay, all right, so let's go ahead and take a look and see what we've got. This next one, does everything get its signs changed, or just the X thing, X part? All of it, right? So this becomes, this one would be the whole, yeah, that's a great way of putting it. Thanks. Whole equation changes sign. So
Oh, so it wouldn't be the y became negative? So
oh yeah,
excessive
so you can
split?
see, yeah, y became negative y. Perfect.
Okay.
So this is across the x-axis. And the next one, did the x become negative x, or did the y become negative y? This didn't change, right? Yeah, because x became negative x. So negative x to the third is negative x to the third. Negative x squared is positive x squared. So this is x became negative x. So that's across the y-axis also. Good? Okay, great. So we're going to move on to our next, which I think is maybe, nope. Yes. So homework lost in vertical translation. This is due Friday, October 8th, I think that is. So write that in. All right. Now we're moving on. So our first thing we talked about was reflection, right? Now we're going to talk about translation. Let's have Ryan, go ahead and read for us.
The problem of communicating across different ethnic, cultural, language, age, or gender boundaries can result in miscommunication or misunderstanding when what is really being said is lost in translation. But there's another meaning for the word translation. In mathematics, the translation of an object refers to a change in its position.
Keep going.
In the rectangular coordinate system, xy plane, objects can move in one of two directions. Horizontally, the object moves left in the direction of the negative x-axis, or right in the direction of the positive x-axis.
All right, so you guys, that means, hold on a second. So that means this way, right? So the object moves this way or that way. Keep going.
Vertically, the object moves upward in the direction of the positive y-axis, or downward in the direction of the negative y-axis, parallel to the y-axis.
Perfect. So that means it goes either this way, up, or it goes down. Right? So a point is somewhere in the axis, and it can go left or right. That's horizontal translation, or it can go up and down. That's vertical translation. Good? Oh, and there's a picture. So
Seems to be what we were just doing, right? Horizontal and vertical.
no, that was okay. So this is different. So reflection means that you go from here to there. Translation, this is reflection. Translation would go from there to there.
Oh.
Do you see what I'm saying?
Okay.
Do you see how it's different?
Mhm.
Right? So I'm not saying maybe I should shift it over more so that it's not quite as mixed up. You go from over there. So it means that you're taking the same thing and you're just moving it just like it is over, not reflecting it. Right? There's a difference. Yeah. Thank you for that question. Graphically, to translate, so that's kind of it, right? You can kind of see. So it looks like I translated it, here like to the right, to left 5 and maybe down 1 or something like that. It got shifted over. Good. So if you're moving it vertically, that means we're change the, that's what we're going to talk about this one, is is when you're moving it up or down. So here, my y is going to change. My x stays the same if I move it up or down. Do you guys see what I'm saying? So, so to shift the point AB upward by amount k, upward by k, I would just add k to the end. Okay, so let's use real numbers. So let's say shifting the point 2, 1. If I want to shift it up 3, right? Up 3, I would just add 3 to the y. This becomes all of a sudden, boom, 2, 4.
Oh.
Everybody kind of on board with that?
Uh-huh.
Yeah? Okay. Again, and if I wanted to drop it, lower it, I would subtract it from there. If I wanted to move it down 1, I'd go 2, 0. I would just move it down. So this adding or subtracting from that spot moves it up or down. So that's the graphically. Exercises. We suggest that you use different colors when you shift them, but you're gonna be doing this for homework. So what you're gonna do is you're gonna pick a point, label it. So what's this point here? From the origin, I go right 3, up 3. So this is 3, 3. And I'm going to shift it, let's see, up 2. So if I shift this up 2, I'm going to move it up here. And that becomes 3, 5. I'm going to use a different color. So ideally, you'd get 2 different colors of pens and do this. I'm going to shift it down 1. So this, maybe I'll use a different color, green maybe. So this becomes 3, 2. Right, so you guys can do that for the other 4 points. Everybody good with that part? You're going to label the first point, and then you're going to shift it up 2, label that one, shift it down 1, label that one. Just like I did with this point. Okay, next part. We're going to do the same thing only with figures, the whole figure. All right, so here is my clue, here's my comment to you. Do 1 point at a time and draw the line each time. Why? Because I end up with all sort of crazy stuff where people give me something that looks like bump, 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 bump. Instead of, now is this the same shape as that? Is that the same shape? Look at the purple one. Look at this one. Is that the same shape?
No.
No, it's totally not the same shape. Because they didn't draw them in order. So, what you want to do is, they drew them out of order. It should have gone here first, then there, then there, then there, then up, right? So they did it, you know what I'm saying?
They connected the dots wrong.
They connected the dots wrong. That's a great way of putting it, right? So they connected the dots wrong. So what I'm saying is, if you want to go up 1, and then where does this one go? Over there, up 1, draw the line. And then where does it go? It goes to here. Make that up 1. Then draw the line. Do you guys understand what I'm saying?
Yeah, step by step.
Yeah, step by step. So do that up 1 unit and then also do it down 3 units. And then you'll do the same thing here, right? Shifting it up 1, down 3. I feel like that's fairly, you guys should be good with that part. Okay. So you don't have to label. See how these ones don't say label the dots? This one says, this one says label the dots, the shifted points. The first one, I want to see that. These ones don't say label the dots. You do not need to label the dots for 2 and 3. Do you guys see the difference? Doesn't say 2, you don't have to. All good.
We're not doing the table? For the
Nope.
points?
Nope, no table. You're all good. All right. You're keeping it simple. Now, this is where it gets a little more complicated. Symbolically. Vertical translation, my y becomes, if I shift up 1, or up, it says I shift up 2, I shift up 2, my y becomes 2 bigger. Everybody agree with that? So the nice thing is, since this function is equal to y, all I got to do is make this function 2 bigger. So I can just add 2 to my whatever my function is, tack a plus 2 on the end, and it'll go up 2, the whole function. Or if I want to move it down 3, I can just tack a minus 3 on the end, and it'll go down 3, because it's already, this is y. So I'm just making my y 3 smaller. It's saying, make y 3 less. So that's super straightforward. So all you got to do is take your function. Say I've got a function, here's my function, f of x is equal to 2x minus 3. I want to shift it up 4. All I got to do is write my function. I'll call it a new function, so it's not f of x, it's a shifted function, g of x, is equal to my old function. Up 4, boom, plus 4.
Like
Right.
non-like terms.
And then, exactly, thank you. So then like Fox says, combine like terms. Which ones are like terms? The $1, right? So here I have 2 skateboards. I owe $1, I have $4. I can combine the dollars. Right, so then I have $1. Right, I owe $3, I have $1. My net worth is $1. Good? Okay. So you guys are going to do this one. Right, so you're going to do all these ones. Okay, so here's the thing. You cannot go inside absolute value function or square root function. You can't go inside it. So you're just going to put it on the outside and you're done. In other words, for example, if f of x was equal to absolute value of 2x minus 1, I wanted to go down 3, oops, sorry. I would do g of x equals absolute value of 2x minus 1 minus 3. Do you guys see what I'm saying?
Yeah, you don't touch that.
You can't touch that.
Yeah.
Think of these like fortress walls. You cannot go inside of them. So,
is that the
that's it.
simplified term?
That's a simplified term. Yeah, that's it. Nothing more. You can't do anything else. Same thing's true with the square root. You leave it alone. You cannot go inside there. You just leave that sucker alone. And just leave it on the outside. Done. Everybody good? Okay. And then this one, you're going to be doing the same thing. What I care about is this part here. I care less if you do the table. I don't care if you do the table. You can skip the table if you want. So skip the table. But I do want the graph. I want the graph and I want the shifted function. So write this with the shifted function, combine your like terms, and then graph it. So if I'm going to go up 2, I'm going to just take some points and just move them up 2. And then I'm going to draw that new line. Ready? Okay. Same thing as these guys. Again, you can skip, right? Skip that part. Ah, this is kind of fun. All right, so here, you have to say how it's been shifted. So here's, the dark one is the original graph. How has it been shifted, up or down? Up. Is everyone on board?
Mhm.
So it's been up, how much? 1, 2, so pick a point.
3.
Yep, 1, 2, 3. Everybody on board with that part? The amount of shift is 3. Your reason is this. What's this point? What's this point down here?
To,
Jenna, what's this point down here?
0, -2.
Okay, so remember I go left, right first.
-2, 0.
Yep. So first you go to the elevator, then you go up or down. So -2, 0, great. Becomes, so little arrow becomes what? So, Shania, what does it become? -2, 0 becomes what? Where does it go?
2, 3.
-2, 3. That's your reason, done. Everybody good? All right, so that is your homework. You'll have, oh. Yeah, then there's this one, which is sorting it out, the amount of the vertical shift. So then you have to kind of look here and see what's going on with this one. Did I add something to it or subtract something to get there? So from here to there, did I add something or subtract something? So what's different? This part's different.
Added 6.
Yeah. So here, I do the reason first maybe. I added 6. So it means that did I go up or down? Up, because you added. And then the amount of shift was 6. Does that, you guys kind of make sense?
Yeah.
Okay. All right. So that is that one. I think is that the last part of that? I believe it is.
Yes.
Okay, so now, that's the horizontal. Horizontal is super easy, super straightforward. We love horizontal. Everybody loves horizontal.
Oh,
Oh, sorry, vertical. Sorry, my bad. I meant vertical. Everybody loves vertical. Vertical is great. Now we're going to talk about horizontal, which is trickier. Can you pass this down?
put 1 form. Oh,
Sorry.
you know, on my schedule it said 11 to 1. I was reading it too in Castro Valley.
All right, so horizontal.
Miss Sam,
Yeah,
I need to head out.
okay.
It was written on my schedule wrong. I thought we ended at 1.
Oh, my bad.
But that's just for this one.
Okay.
I'll be home.
Sounds good.
Thank you.
Thank you for coming. I want to say thank you, June.
And I will see you all next week.
Cool.
Thank you.
Okay, now, just as a reminder, horizontal translation is when you go side to side along the horizon, right? Vertical translation is when you go up and down, you translate up or down. Horizontal affects your x's, right? If I'm, I'll show you what I mean. If my x is here, and I shift it here, I've gone 3 to the left. Everybody with me on that part? I start off with the horizontal, and then I end up over here. So in terms of graphical's super straightforward, very easy. It's what you expect.
What is this do? Is this also doing Friday?
This is, oh no, this is what we're gonna do in class.
Oh,
We're gonna do this one right now together. So here, again, this is 3, 3. Oh, I should write it in a different spot. Write it above, because then you'll have more room. 3, 3. If I shift it right 2 units, right 2, it goes here. Now it's 5, 3. you'll notice what happens. The X becomes 2 bigger, right? It went from 3 to 5. If I shift it back, left 1, if I shift this left 1, it goes here. So what's that? This is 2, 3. Again, my X has changed. My X has become 1 smaller. Good? Okay, so everybody take a couple minutes and label the rest of these 4 points. And then shift them all. So it's a lot of labeling, right? Label it, shift it, label the new shift. So I would do it point by point. Right, so what I would do is I would do this one. I would do this one next, label it, shift it 2 to the right, label that one, shift it 1 to the left, label that one. We'll take a couple minutes, we'll do that. So if you're at home, pause now, and then resume when you're done. Okay. Pause the video is what I meant. Okay, so here, these ones are the original ones. This is 1, -1, 2. If I shift it to the 2 to the right, it becomes 1, 2. To the left becomes 1 to the left becomes -2, 2. This guy is 0, 0. That's an easy one. 0, 0. I love that one, right? If I go right 2, it becomes 2, 0. If I shift to the left, it becomes 1 to the left becomes -1, 0. And then this one here is 2, -2. So 2 to the right becomes 4, -2. And 1 to the left becomes 1, -2. This guy is -4, -3. And if I go to the right, it becomes -2, only -2, -3. My 3's are kind of weird, sorry, it looks like a 1 and 3. And then this one becomes -5, -3. Okay. So if you didn't finish it, just finish it later. That's totally fine. And just check your answers against the answers on the board. I think we're good with that. I'm comfortable with you guys doing that. So let's take a look at this one here. Shift the rectangle by shifting the 4 corners and redrawing the rectangle. So here we're going to do the same thing we did last time. We're just going to shift it right 2 and left. So do right 2 and then draw a triangle. And then shift it left 1 and then draw a triangle. Does that make sense? The new triangle. So again, I would do it point by point maybe and say, okay, so this first point, right 2. There we go. Next point, right 2, draw a line. Right, and the next point, this point, right 2, draw a line. Right, and then finish it out. So I'd say do it piece by piece like that, so you end up with triangles at the end. And the bottom one, same thing. Right, you're going to shift it. So I would say pick, easiest way to do this, on your homework, same thing. Easiest way to do this is when you pick the endpoints, kind of those ones, and shift those and kind of shift it with it. You know what I'm saying? All right, so why don't you guys work on those 2. And we'll stop there for now. We'll come back. So work on those 2. If you're at home, pause the video right now and work on those 2, and then we'll come back to that in just a minute. Make sure that you do a dot, do another dot, connect those lines, and then do the other dot, connect those lines. So you're going to do all your A's first, right? Shift, 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 shift right, shift right, shift right, connect those dots. And then the shift lefts, do those. Don't do them both at the same time because you don't know which dots to connect. Does that kind of make sense? So here, we'll go through them. So here, I did all the right 2 units first. Now, and it helps if you do it in color, maybe, I'm going to do all the left 1 units. So this point, left 1, this point, left 1, this point, left 1, connect them. And you'll see I've got this triangle, and I've got two versions. I've got a version to the right of it and a version to the left of it. They look the same. Same thing here. I'm going to go right 3, right 3, right 3, right 3, and I'm going to connect them. And then, after I've done that, then I'm going to do B. B is left 2, connect. Next one, left 2, connect. Good? Okay, so now, let's take a look. I'll make it smaller. Okay. So, it appears that you just need to add the amount of horizontal shift to the x-coordinate to shift the point to the right and subtract the amount of the horizontal shift to move it to the left. And that totally works graphically. So graphically, we're going to do just what we do. If you shift to the right or the left, you're just going to subtract and add to that x coordinate. But it doesn't work for the function. Why is it?
Because x is in the equation.
Yeah, because x is in the equation. That's a good way of putting it. So we're going to do this. We're going to cross this part out. I'm going to explain it to you instead on paper. So y equals, say, 2x minus 1. And I want to shift, I don't know, 3 to the right. With the y, it's easy because I can just make y 3 larger. So I just add 3 on the end. If I want to do that for x, I could do that, except I'd have to solve for x first. So I had x equals. So if I did that, you don't have to do this, but I'll show you what I mean. If I did that, I would do, okay, how do I solve for x? I would add 1 to both sides. First I'm going to draw my little railroad for success down the middle, so then I've got this right here. And so on this side I'm going to do plus 1, which means on this side I have to do plus 1. So then that would give me y plus 1 equals 2x. And then what's the last thing I need to get x by itself?
Divided by 2.
Divide by 2. Everybody are okay with that part?
Mm-hmm.
Okay. So you can divide both sides by 2. So then I have y plus 1 over 2 equals x. Okay, I want to shift 3 to the right. I just make x 3 bigger. So then I'm going to do my shift. 3 right. This becomes y plus 1 over 2 plus 3. Shift 3 to the right. Everybody okay with that part? That will do it. But now I need to solve back for y, because that's what we need to be in. So how do I do that? First I need to subtract 3 from both sides. Right? My bad. Let me draw these lines in a different spot. Subtract 3 from both sides. That's a lot easier. So then we end up with y plus 1 over 2 equals x minus 3. So now I'm trying to solve for y. So you need to put it back in terms of y. Now I need to multiply both sides by 2. So I'm going to multiply this side by 2, multiply this side by 2. And I'll get y plus 1. Right, that gets rid of my 2. Equals 2 times x minus 3. All right, so then what's the last thing to do to solve for y? What was that? Subtract 1, yep. I need to subtract 1 from both sides, so I get rid of this plus 1 from the y side. And I'll end up with y equals 2 times x minus 3 minus 1. So what did I start with? I started with the original was y equals 2x minus 1. What I've got is, it looks almost the same, doesn't it, guys? I mean, I've got the 2, I've got the minus 1. The difference is that my x has become, in parentheses, x minus 3. Does anyone see that? This is still here.
Oh,
This is still here. Difference is that, those, you can't really see the color changes, can you? It's a little darker on my screen. So these guys stay the same. The difference is that this x became x minus 3. Does everyone see that? So the 2 stayed the same. The minus 1 at the end stayed the same. The difference is my x becomes, in parentheses, x minus 3.
I see.
So I'm substituting x minus 3 for x.
So in this case, you just minus it off the x every time, or plus it off the x, you just rewrite it.
Exactly.
Yeah.
Yes. Did you guys hear what he said? This case, you're just going to plus or minus and subtract it off the x instead
Instead of the whole thing.
of the whole thing,
Yeah.
in parentheses. Now the key is, I went to the right 3, and I'm subtracting. Why is that? Because I want my x to be 3 larger. This needs to stay the same. But if I make x 3 larger, then my y needs to stay the same. So the whole thing needs to be the same. If I need my x to be 3 larger, then to make it fit into the equation, I have to do x minus 3. Or let me put it this way. The way that I think of it is, because I had to do it to the opposite side of where the x is, then to move it back over, I had to subtract 3 from x, because it's on the same side of the equation as x is on. The y, if I want to move it up or down, I just add it to the other side. But because I'm doing it to the same side that x is on, it's the opposite. Like subtracting it from this side is the same as adding it on this side. Do you guys kind of see what I'm saying? I added 3 to this side, but when I moved it back over to the same side as x, I had to subtract it. Adding on this side is the same as subtracting on this side. So that's what happens. So that's why in the equation part, the symbolic part, you do the opposite. And you could think of it, maybe you think of it this way. This might help too. You can also think of it as, I have, this is the old one. Say the old one was, let's see if I put in 0 for x, I get 0, negative 1. The new one should be what? If I go up 3, or to the right 3. Right?
Plus 2.
Right 3 should be 3 comma negative 1. Is everyone good with, do you guys understand what I'm saying? If I'm shifting to the right 3, my old one was 0, negative 1. My new one should be 3, negative 1. Everybody all right, that part? So this was my old x. So this part needs to be 0 for this part to be negative 1. So it means that this whole part here needs to be 0 in order for this to be negative 1. So how does this part become 0? When x is 3. Right? So when my x is 3, then this still stays at 0. So that's why I have to do whatever the x is minus whatever the shift to the right is. So do you need to remember all of that? Well, no. If you just remember the bottom line, which is this. The bottom line is, to shift horizontally. Oh, sorry, we are out of time. Horizontally, if it's graphically, just add to X to go right. But if it's symbolically, you subtract.
So essentially, you're just trying to get y to 0 and plug in what you know x is going to be.
Yeah, yeah, exactly. All right, have a good weekend. I'll see you guys. I won't see you on Monday. No class Monday. We'll see you guys on Wednesday.